Alright, so I told you guys about the unit circle. By the way, keep that out for this section and probably for the rest of the semester, so have a nice one drawn someplace. My cat wants to say hi to you. I'm just breaking this up because, quite honestly, I made like, I don't know, 8 videos so far, so I'm getting kind of slap happy. Alright, Garfield, say hi. I don't know if you guys heard him. He talks. Garfield, say hello again. Okay, good boy. Alright, so anyways, let's do this next section. Find the value of sine, cosine, tangent, cosecant, secant, and cotangent if the point equals negative radical 3 over 2, comma, negative 1/2. Well, hopefully you remember that the first coordinate is cosine and the second coordinate is sine. And because it's a unit circle, by the way, you have to have that in the sentence to make this work. If not, you have to find r. So we know that the radius is 1. So we can go ahead and quickly put down that cosine of the angle. And by the way, you also know what the angle is, but it's 120 degrees, if you guys believe me, hopefully. Or actually, it's not. It's 180 plus 30 degrees. So 180 plus 30 is 210. I wrote the wrong value down there. Okay, so cosine of 210 degrees, all I have to do is read off the value. It's negative radical 3 over 2. So secant of 210 degrees, I'm going to flip this over, so it's going to be negative 2 over radical 3. Rationalize it. I get negative 2 radical 3 over 3. Okay, next, sine of 210 degrees equals negative 1/2. Its reciprocal function is cosecant, and it equals negative 2 over 1, which equals negative 2. And finally, tangent of 210 degrees. Tangent of 210 degrees, we're going to have to do a little bit of math here. 1/2 over negative 3 over 2. Why did I do that? Because tangent is defined as sine over cosine, or y over x. This equals negative 1/2, and then we flip over the denominator to be able to multiply it. The 2's cancel each other out, and I get 1 over radical 3. Rationalize that, I get radical 3 over 3. Okay. Cotangent of 210 degrees is the reciprocal of 1 over radical 3. So it's going to be radical 3 over 1, or just radical 3. Okay. You know what I do before I accept these answers? I quickly check, because I am in quadrant 3. The only thing that's positive in quadrant 3 should be tangent and cotangent, and that's the case, and everybody else is negative, so this is right. By the way, if you're wondering how I got 210 degrees, I looked at my values of sine and cosine, and I knew that came out from the 30, 60, 90 triangle. So I know that sine at 30 degrees is 1/2. So I figured we were in quadrant 3, so I added 180 plus the 30 degrees and got 210. So that's how I got it, just to let you know. Alright, objective number 2. Know the domain and range of the trig functions. I don't know why the heck they put this in this section, but they did. We're going to be looking at the graphs of all these functions when I get back, and it'll make so much more sense. So really quickly, sine is equivalent to y, cosine is equivalent to x, tangent is y over x, where x can't equal 0, because we can't divide by 0, that's why that is. Cosecant is a reciprocal function of sine, so it's 1 over y, where y can't equal 0. Secant is the reciprocal function of cosine, so it's 1 over x, where x can't equal 0. And then cotangent is x over y, where y can't equal 0. Okay, so we've seen these definitions over and over and over again. The domain. The domain of sine and cosine is all real numbers. When you see the graph, you're going to see that the functions look like this, and I'm just quickly drawing it. Here's the x-axis. So they go on and on and on forever in the x direction. So remember, domain goes with your x values, usually. And range goes with your y values, usually. So your domain for sine and cosine, and when, like I said, when you see the graph, it totally makes sense, is all real numbers. Okay, tangent. So tangent and secant get a little tricky. Please get out that image of your unit circle, and I want you to look up pi over 2, which is 90 degrees. So remember, tangent at that value, or the values are 0, 1, and tangent is y over x. So tangent is undefined, as is secant at pi over 2. When we see the graph of tangent and secant, we're going to see that there is no value there because it's undefined. You're going to see what's called an asymptote. Hopefully you guys have heard that word before, at those values. So the domain of tangent and secant gets a little bit hairy because we got to look at the rest of the unit circle. If you look down below at 270, the value is 0, -1. So we have the same situation where we find tangent and we got a problem. So the domain is odd multiples of pi over 2. Okay, odd multiples. Odd numbers mean 1, 3, 5, 7, etc. And pi over 2 and then 3 pi over 2. The next one would be 5 pi over 2. So that's how I got odd multiples of pi over 2. My dog's now saying hi to you as well. This is the best recording ever. Anyways, domain of cotangent and cosecant. There are holes in the domain of cotangent and cosecant as well. The domains of the cotangent function is a set of all real numbers except for integer multiples of pi. All right, why is that? If you look on the unit circle at pi, or 180 degrees, we have the values of -1, 0. Okay, if we're defining cotangent, remember it is x over y. So -1 over 0 is undefined. Cosecant, remember that is the reciprocal function of sine. Okay, so reciprocal function of sine means we have 1 over 0 at 180 degrees. That causes trouble as well because that's undefined. So the domain of both is all real numbers except for integer multiples of pi. Integer means 1, 2, 3, 4, 5, 6. So we're going to have the problem at pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay, like I said, when you see these graphs, this is all going to kind of sink in. The range. Remember, range is all possible y values. Okay, so all possible y values. That is your range. I like to tell my 1033 class that, you know, you're looking for the height of the graph. That is your range. So the range of sine and cosine are -1 to 1. That's because the height of the graphs, when you see them, the height of the graph for the normal one goes up to 1 and goes down to -1. So that's going to be the height of it. And the range for cosecant and secant, they will go over the values of 1 and including 1, and they'll go under the values of -1 and continue onward. So you're going to see that cosecant and secant, because they're reciprocal functions of sine and cosine, will actually ride on the back of the graphs of sine and cosine. But like I said, we're going to see that a bit later. Okay. The domain of cotangent and cosecant is the set of all real numbers except integer multiples of pi. Same reason we just talked about that. Actually, I just did this part. So I don't think I did this right here. Cosecant and secant, the range or the height of it is any value including -1 and above, and any value including 1 and above, -1 and below. Okay, the range of tangent and cotangent is all real numbers. That one's the easy one. The graph kind of looks like this, so it goes on and on forever. Okay, moving on. All right, this table right here, you need to know, but like I said, next section will really make this clear. It's giving you the domain and ranges of every single one. So please have those memorized. Like I said, when you see the graph, you can put the pieces together. Okay, objective number 3, use the periodic properties to find the exact value of trig functions. We're going to look at where sine and cosine's values start to repeat themselves. We know that we don't have any restrictions in the domain of either one, so the values repeat themselves after 2 pi, or 360 degrees. Okay, so sine, cosine, secant, and cosecant, all the reciprocal functions of the values, the period is 2 pi. That means that all the values start repeating themselves after 2 pi. By the way, period is going to be written as a capital letter T. So just keep that in mind. We'll need that a bit later. Okay, so this definition here that I just starred, these two are just saying that your values are repeating themselves after 2 pi, so you can revert back to the first, second, third, and fourth original quadrants to find the values. Okay, a function f is called periodic if there is a positive number p such that whenever theta is in the domain, we can add the periodic function to it and get the original value. Okay, so tangent and cotangent have periods of pi. They repeat themselves after a pi unit of time. So they're kind of off on their own. So I just want to let you know that they're going to be a little bit different. Okay, so here I think is the last problem of the section. I'm going to go ahead and finish it out, even though this video is getting a little bit long. Alright, it's asking us to find sine of 420. So just like we found the reference angles, the first thing I'm going to do is subtract 360 from that, because I want to know where I'm at. And I get 60 degrees. So I'm actually looking for sine of 60 degrees. Once again, at this point, you can use either your unit circle or you could use the triangles. I like to use the triangles, so do the physics teachers. They get really happy when you use them. So sine of 60 degrees is radical 3 over 2. And we're in quadrant 1, so I know that value is positive. Part B, 5 pi over 4. Well, I know that 5 pi over 4 is in quadrant 3. How do I know that? Because pi is equivalent to 4 pi over 4. So if I turn that into degrees, if you want to, the degree value is going to be 45 degrees plus 180. And you get 225. Okay, so tangent of 225. Alright, you can use your unit circle, by the way. It'll make life much easier. But I know that tangent of 45 degrees is 1. Being that we're in quad 3, I know tangent's positive, so my answer is going to be the value of 1. And once again, you can divide your unit circle values of sine divided by cosine. So just remember you could do that as well. Okay, part C. We have 11 pi over 4. Well, I know because the denominator is a 4, it's a 45-degree angle. If I double the denominator, I get 8 pi over 4. And the reason why I'm telling you that is because that's equivalent to 2 pi. So if I take 11 pi over 4 minus 8 pi over 4, I get 3 pi over 4. 3 pi over 4 is in quadrant 2. How do I know that? Because pi is equal to 4 pi over 4, and this is 1 less than that. So you can look on your unit circle at the value of cosine at 3 pi over 4. Or I know that it's a 45-degree angle, and I know cosine is radical 2 over 2. If I refer to all students take calc, I know the only thing that's positive in quadrant 2 is sine. So therefore cosine is negative. And once again, if you look on your unit circle, you would see what I just said is true. Okay? So I did A, B, C, and that's it. Oh, there is an objective 4. Okay, I'm going to actually stop this recording and I'll make one more video. So there's going to be a part 3 to this.